In previous lecture, we have talked about how to find inverse of a matrix. Today we'll take few of the examples on that. So first of all, let's do a question that says find the inverse of matrix capital A is equal to 1 3 3 1 4 3 1 3 4 and verify A inverse A is equal to I. Solution. Now first of all, we know a matrix is invertible or the inverse exists only if its determinant is non-zero. So first of all, we try to find the determinant of A. 1 3 3 1 4 3 1 3 4. So it is 1 into 16 minus 9 minus 3 into 4 minus 3 plus 3 into 3 minus 4 comes out to be 7 minus 3 minus 3 is equal to 1, not equal to 0. So clearly determinant A is not equal to 0 implies A is non-singular, implies inverse of A exists. Now we have obtained a formula that says A inverse is 1 upon determinant of A into adjoint of A. Determinant A we have already found, which is 1. And what about adjoint of A? To find adjoint of A, we need to find the cofactors of each element of the matrix. So let's first of all find out the cofactors of the matrix. So that will give you C11 is equal to minus 1 raised to power 1 plus 1, 16 minus 9, it is 7. C12 minus of 4 minus 3 is minus 1. C13 is equal to 3 minus 4 minus 1. C21 it is minus of 12 minus 9 is minus 3. C22 it is 4 second row second column minus of plus 4 minus 3 1. C23 second row third column it is 3 minus 3 0. C31 it is third row first column 9 minus 12 minus 3. C32 it is minus of, so third row second column 3 minus 3 0. C33 it is third row third column 4 minus 3 1. So that's how we found the cofactors of each element. Now what about adjoint of A? Adjoint A, this is replace each element of a matrix by its respective cofactor. You will have 7 minus 1 minus 1 minus 3 1 0 minus 3 0 1 and take its transpose. So the adjoint comes out to be 7 minus 1 7 minus 3 minus 3 minus 1 0 minus 1 1 0 minus 1 0 1. So that's how we found the adjoint of the given matrix. Now to find the A inverse, again check it out. We have the formula that says A inverse is equal to 1 upon determinant A into adjoint of A. So 1 upon 1 into adjoint of A. 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So A inverse is equal to 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. That is your A inverse. Now to verify A inverse A is equal to I. A inverse A is equal to, now A inverse is 7 minus 3 minus 3 minus 3 1 0 minus 3, sorry, 7 minus 1 minus 1 minus 3 1 0 minus 3 0 1 multiplied by A 1 3 3 1 4 3 1 3 4. So you'll have 7, sorry, I made a mistake. That was adjoint of A. A inverse was 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1 multiplied by 1 3 3 1 4 3 1 3 4. So you'll have 7 minus 3 minus 3, 21 minus 12 minus 9, 21 minus 9 minus 12, it is minus 1 plus 1 plus 0, minus 3 plus 4 plus 0, minus 3 plus 3 plus 0. Then it will be minus 1 plus 0 plus 1, minus 3 plus 0 plus 3, minus 3 plus 0 plus 4. That comes out to be 1 0 0 0 1 0 0 0 1, which is an identity matrix. Hence, A inverse A is equal to I. Similarly, you can show that A inverse is also equal to I. That I leave it up to you. So this is one kind of question where we find the inverse of a matrix by finding the adjoint of the matrix. Next kind of question is where we verify that AB the whole inverse is equal to B inverse A inverse. That is, in second kind of questions, we verify the reversal law. So let's take a question that says if A is equal to matrix 2 1 5 3 and B is 4 5 3 4, then verify AB the whole inverse is equal to B inverse A inverse. This we are required to verify. Solution. First of all, let's find out AB. That is 2 1 5 3 multiplied by 4 5 3 4. So this multiplied by this, you will have 8 plus 3, 10 plus 4, 20 plus 9, then it will be 25 plus 12. So this is 11, 14, 29, 37. Now we need to verify whether AB the inverse exists or not. For that we need to find the determinant of AB. Determinant of AB, that is determinant of 11, 14, 29, 37. That comes out to be 77. 11 33 plus 7 40 minus 126, 12, 406, 1 not equal to 0. So AB the whole inverse exists, and adjoint of AB. How to find the adjoint of 2 by 2 matrix? It is interchange the diagonal elements 37, 11 and change the sign of off diagonal elements, that is minus 14, minus 29. What I have done is interchange the diagonal elements and change the sign of diagonal elements. So remember this thing, we are going to use this thing for another time, one or two times more in this question. So what about A inverse? A inverse is 1 upon determinant of AB into adjoint of AB. So this is 1 upon 1 into 37 minus 14 minus 29, 11. So it will be 37 minus 14 minus 29, 11. Mark this as number 1. So we have found AB the whole inverse. Now let's find out B inverse into A inverse. So here we write AB the whole inverse is equal to, what was that? It was 37 minus 14 minus 29, 11. We have marked it as number 1. Now determinant of A, that is determinant 2, 1, 5, 3. 6 minus 5, 1. Determinant B, that will be 4, 5, 3, 4. 16 minus 15 is equal to 1. Clearly, A and B are invertible. How? Because their determinants are non-zero. Next is adjoint of A. Now how to find adjoint of A? As I told you earlier, interchange the diagonal elements and change the sign of diagonal elements. So this implies A inverse is 1 upon determinant of A into adjoint of A. So since determinant A is 1, so A inverse will be equal to adjoint A. So this is 3 minus 1 minus 5, 2. Similarly, adjoint of B. Again, interchange the diagonal elements and change the sign of diagonal elements. So this implies B inverse will be 1 upon determinant of B into adjoint of A. This is also determinant B is 1. So B inverse will be equal to 1 upon determinant B into adjoint of B. So B inverse equal to adjoint of B, which is adjoint of B, 4 minus 5 minus 3, 4. Now we will find B inverse A inverse, that is 4 minus 5 minus 3, 4 multiplied by 3 minus 1 minus 5, 2 is equal to, it will be 12 plus 25 minus 4 minus 10, then it will be minus 9 minus 20, then it will be 3 plus 8. So that will be 37 minus 14 minus 29, 11. Mark this as number 2. From 1 and 2, what you will get is AB the whole inverse is equal to B inverse A inverse. You can verify AB the whole inverse is equal to B inverse A inverse. So that is second kind of question you can encounter with. And third kind of questions that come across is to find the inverse by using matrix equation. To find the inverse by using matrix equation. Like we take a question, show that A is equal to 5, 3, minus 1, minus 2 satisfies the equation x square minus 3x minus 7 is equal to 0. Hence, find A inverse. So, solution. First of all, we found A square. A square. That is A into A, which is 5, 3, minus 1, minus 2, multiplied by 5, 3, minus 1, minus 2, which is 25, minus 3, 15, minus 6, then it will be minus 5 plus 2, then it will be minus 3 plus 4. So this is 22, 9, minus 3, 1. So let's find out A square minus 3A minus 7I. So this will be 22, 9, minus 3, 1, minus 3 times A, which is 5, 3, minus 1, minus 2, minus 7I, which is 1, 0, 0, 1. So that comes out to be 22 minus 15 minus 7. This is 9 minus 9 plus minus 0. Then it will be minus 3 plus 3 minus 0. Then it will be 1 plus 6 minus 7, which is 0, 0, 0, 0. Null matrix. So A square minus 3A minus 7I is equal to 0. Implies A satisfies the equation x square minus 3x minus 7 is equal to 0. So A square minus 3A minus 7I is a metric equation which satisfies the algebraic equation x square minus 3x minus 7 is equal to 0. Now, how to find the inverse by using this matrix equation? Now, we have just proved that A square minus 3A minus 7I is equal to 0. This implies 7I is equal to A square minus 3A, or 7A inverse I is equal to A inverse A square minus 3A. What we have done is pre-multiplication with A inverse. So 7A inverse is equal to A inverse A square minus 3 A inverse A, because AI is equal to A. 7A inverse is equal to A minus 3I, because A inverse A is equal to I. So A inverse is 1 by 7 times A minus 3I, which is 1 by 7 times A, which is 5, 3, minus 1, minus 2, minus 3I, 1, 0, 0, 1. So this is 1 by 7 times 5 minus 3, 2, 3, minus 1, minus 2 plus minus 3, minus 5. So A inverse is 1 by 7 times 2, 3, minus 1, minus 5. So you can see we can find the inverse of a matrix by using elementary row operations, or by using adjoint of a matrix, or by using a matrix equation. Now the question is, if the question comes in an exam to find the inverse, then which method is to be used? If it is simply asked to find the inverse of the matrix, then you can use any of the methods. But if you have been asked, solve the equation and hence find the inverse, then you need to use the equation to find the inverse. If you have been asked to find the inverse by using elementary row operations, then you have to find it by using elementary row operations. You cannot use adjoint over there, you cannot use equation over there. So if method has not been asked, then you are free to use any of the methods. But if a specific method has been asked in a question, then you need to do the same which have been asked. Thank you.